So we're looking at functions. Functions have at most one output value for any input value. And we will look at this in more detail, and it's discussed a lot in Algebra 2 and Pre-Calculus. But our textbook ends with functions, and there's quite a few things to say about functions, but I just want you to first acknowledge the importance of math history, and just learning that some of these details that are coming in the late 12th century from an Arabian mathematician. When he talked about functions, and that's one of the places we see that discussed. But we also know about function notation, which comes from a Swiss mathematician, or from a mathematician who lived in the Switzerland area and then Prussia and so on. His name was Leonhard Euler, very prolific mathematician from back in the day. So I really want to encourage you to look into math history and study the big background of some of these things. So Euler came up with the notation f of x. He also popularized pi, as we write pi, that notation, and then the letter e, sometimes called Euler, the Euler number. But anyways, math history is fascinating. But let me just show you an example of how functions can work. So you look at this, f of x, okay, is equal to x squared plus 2. That means whatever you have here, okay, whatever I have here will come up there. And so if I have f of 5 with this same function, that would be 5 squared plus 2. If I have f of 10, it will be 10 squared plus 2. Do you notice the pattern of my input value, and then it goes into the equation, and I can solve that. Now the graph for x squared plus 2 would be more of the blue line, the blue marker you see. It moves up 2 spots, okay, from the parent function. So notice there's the parent function. The parent function, of course, we have a quadratic. So we have parent functions for different things in mathematics. So it's important to be able to identify quadratic versus an absolute value, okay? And of course you have the equation of a line, you have the cubic function, the square root function, and so on. So functions have at most one output for any input. But there's another type of function I want to discuss, which is when we deal with trigonometric ratios and functions. And so if you're given 3, 4, 5, a 3, 4, 5 right triangle, now notice that Pythagoras triples, 3 squared plus 4 squared is actually equal to 5 squared. And this also works with 5, 12, and 13. So knowing your Pythagoras triples can help you as you learn the sides of a right triangle. So this will be, again, 3 squared plus 4 squared is equal to 5 squared. Okay? And when you're dealing with this, and I ask you to find a missing angle, for example, well, you would have to use sine. We have sine, we have cosine, we have tangent. Okay, those are the 3 basic trigonometric functions. And so if we can look at, if someone asked us, what is sine theta? Sine theta would be opposite over hypotenuse. But let's quickly look at what that means. The longest side of a right triangle is called the hypotenuse. Okay? Hypotenuse. The side across from the opposite is called opposite. And the side left there is the adjacent. Okay? So you have the hypotenuse, the adjacent, the opposite. And when you're dealing with sine theta, here opposite of hypotenuse, cosine theta is adjacent over hypotenuse. So in sine theta, the answer would just be 3 over 5. And cosine would be 4 over 5. Okay? Tangent is opposite over adjacent. And in this case, it would just be 3 over 4. So there's a way we remember. Notice it's SO, S-O-H, Ka, C-A-H, Toa, T-O-A. So SO, Ka, Toa would be the notation we use to figure out the different trigonometric ratios of a right triangle. Let me know if you have any questions on this. Have a wonderful day, and all the best as you continue.